Hi, welcome to week two. Assuming it's week two, but definitely we're going to start looking at the lecture for chapter two. Chapter two, we're going to be in chapter two for 2 weeks because it's hardware, software. It's a lot of information. Um, a lot of it's just terminology definition, making you feeling comfortable with what it is, what you're dealing with. So today will be hardware. Next week will be software. And between the two, you'll at least have a general understanding of things you probably already know in this. So this was a lot of terminology. I'm going to go through it really quickly. There's not a lot in this that probably requires a whole lot of information. So you may want to make sure you use Quizlet to help get those terms down pat, because that'll be the lion's share of this chapter. So the anatomy of a computer basically has several different parts to it. It's got a CPU, main processor, got memory, input-output devices. And in some cases, you'll see external storage attached to this also. Of course, then that external storage is usually not controlled by the CPU, but there's usually another onboard processor that'll take care of all that stuff. So components of a CPU, it's got basically it's a control. It does mathematical stuff very fast. It controls things, has registers in memory-like locations. It's part of the computer that sequences and executes instructions, and it does clocks. You rate it based on how fast, how many cycles per second can that processor handle. And today we're running between 1 and 4 gigahertz, which is billions instructions per second. So then your memory there are several different types of memories, and we'll go into that. And then you've got input-output devices. Now your processor can be a multi-processor, so I can do multiple instructions at the same time. I can have multiple co-processors that speeds up the process, so I can kind of distribute the work that's going on inside. And in a lot of today's computers, you have multi-core. So there's 4, 8, 16 different processing units that can actually handle instructions in parallel. And when you talk about parallel processing, you'll take an instruction and actually break it apart and send it to each one of these cores and then pull it back together again. That way it speeds up the processing of the data. Now you got parallel computing, like I just said, simultaneous execution of the same tasks, the same instructions. Massively parallel, you're talking about your very fast super computers where they're actually having several thousands, not just 8 cores. They got thousands of processors that are linked together to operate at the same time. And the same thing with grid, a collection of computers that are just coordinated to solve problems. Those massively parallel grid supercomputers type processing. Your main memory. You got to have your CPU needs a place to store information as it's working on it, either for the programs, the data, and it retrieves data relatively fast for the instructions for the CPU. A byte, which is one of the smallest pieces, made up of 8 bits, and a bit's just a toggle 0 and 1. A lot of this is not new to you, but here are some basic size. Kilobit, megabit, gigabit. So a lot of storage out there. Your memory, the type of memory. There are several different types of memory. RAM is your random access. Some of it you got static. Those are used for registers and caches. You got dynamic use. That's usually for your main memory. And then there's several different types of RAM as far as, how much speed, how much processing do you want to handle. Now you sometimes have read-only memory. And read-only is good. It's a non-volatile. That means when you shut the power off to your computer, you don't lose that memory. So you can store things that you want to make sure your system does every single time when there's power. So the programs to boot your system are stored in non-volatile. So it's not as big, but it's definitely, when you shut the power down, you don't lose it. Secondary storage, disk drives, external disk drives, tape drives. They're non-volatile because you can shut the power down to them. Don't lose it. They definitely are cheaper and have greater capacity than you usually can get on your computers that you're buying today. Secondary storage, different types. Secondary storage is not accessible by the CPU, but you've got a separate processor to handle that. And you get magnetic tapes, optical drives, solid state drives. Mag tapes are not used as much as they used to, but you may find some if you go to some older companies. Here you go, virtual tape, mag tape, hard drives. Different types of optical storage, CD, CD-ROM, DVD, Blu-ray, all of those are optical, and it's using light to determine what gets reflected back to it or not, as far as whether it's a 0 or 1 stores. So it's faster, more resilient to change. You can't demagnetize it like you could the old magnetic drives. Solid state. This is where I'm using memory chips versus mag tape, magnetic CDs, optical readers. Definitely less power, no moving parts, no wear and tear, and the prices are coming down to the point where you'll probably find in the next few years that all your PCs will come up that way. Enterprise storage, these are just different large storage operation. Now we've got multiple data centers in the college areas. Apple, Google, they have tons of data, and they've got storage on networks. So storage on networks is basically they've got they're networking data storage units together. So I don't have to keep it all together. Things that these storage networks can give you is they can allow for automatic backup, disk mirroring. So that means contents of one disk is the same as one as another. You write something to one, it's written to two. So if you lose one disk, you have the backup. So a lot of options that if you're willing to pay for it, is there. Just a quick graphic as to that network. So all that storage is routed to some internal network. Storage as a service. You can store, pay money, Google Disk Drive, Amazon's drives, you could pay to have their storage and run it there. Cloud services, you see several options on Amazon there, different ways. Most of you use Dropbox, Google Drive. I like Google Drive over all of these, only because I'm a big Google fan, but that's just personal preference. Input-output devices, you've got several different choices, but basically what is it doing? I'm allowing me to interface to the computer, whether it's a keyboard, a mouse, touchscreen, different choice. So it just depends on how quickly and how quality of the system, how fast, the quality, all of that comes into play. Different types, keyboard, mouse, speech recognition, motion sensor, scanners, optical scanners, as you on and on and on. And most of these you've probably seen and used one way, shape, or form in your day-to-day operations. Different types of displays, flat panel, green, a lot of them are all liquid crystal, light emitting diodes, LED, plasma. Sounds like some of your TVs, doesn't it? Same thing. Those things that you're talking about, what's on your TV, you're seeing now on your computer screens. Two types of major printers that we output devices, LaserJet and inkjet. Different stories, your choice, what you like to use. And then plotters if you're using large drawings, schematics, buildings. but those are probably the major plotters and printers. 3D printers, those are becoming big. What are the options of this? Allows you to is build human body parts. I think some of that stuff kind of gets a little scary, but if you need a individual part, a unique part, throw the program in, your drawing in, and print it. I've had handsets made with 3D printers. Cool stuff. Different types of general purpose computers, single user, multi-user computers, mobile phones, smartphones, laptops, notebooks, tablets, all of these are what? Portability is the big issue. Now, if the school has, some of the rooms have what we call thin clients, and basically all it is a box that has all the I/O outputs in it, no memory, no disk space, and it's forced everything to go back to a central repository, a cloud confinement. Desktop computers, we've used some of the notebooks, the smaller laptops, workstations, a little bit more powerful. Most of the school's computers are more on the desktop size, but there are probably some, if you're running a server, it could be a workstation. Servers and mainframes, all of these are larger, bigger computers, faster, more power, more memory, more processors, more CPUs to handle more complicated tasks. Server farms, like I said, you got Google, Apple in the area, housing large amount of servers. Virtual servers, some of you will be exposed to virtual machines. With VMware is probably the biggest manufacturer of that software. But basically what it has is it has one physical box, and on that will have a bit of software called a hypervisor that controls the individual virtual machine. So you actually load basically you're loading software in that acts like a physical machine. And you can't tell the difference. The data centers, the biggest thing there is controlled access, secure. You don't have to back up your own data. Of course, having that much stuff, you can handle better operations, better energy, better processing, cooler, be able to handle disasters better. So you wonder why Apple, Google, and others have put data centers along 321. Very solid ground structure, and it actually has the largest fiber optic cables between the southeast up to New York City, so a lot of data passes up 321. Green computing, I'm trying to reduce hazardous materials, lower power consumption, have ways of getting rid of old used equipment. So just a way of trying to let the computer industry not be a contributor to the pollution on this earth. So hopefully that gives you a brief summary of the hardware. I know it went through quick, but this chapter is a lot more definitions, and we'll see the same thing on software. So enjoy, have a nice weekend, talk to you later.